Ever wondered what it takes to bring light into our world with just the flick of a switch? For over a century, the incandescent light bulb has been a symbol of bright ideas and innovation. From cozy reading lamps to stage spotlights, its warm glow has lit up our lives in countless ways. But have you ever stopped to think about the incredible journey a simple light bulb takes before it reaches your home? Today, we're going behind the scenes to uncover the complete A-to-Z manufacturing process of this everyday marvel. Get ready to see the humble incandescent bulb in a whole new light. At the very heart of the incandescent bulb is a tiny yet mighty component, the filament. This is where the magic of light creation happens. When you turn on a lamp, electric current flows through this filament, heating it to an astonishing temperature of about 2,500 to 3,000 degrees Celsius. That's hotter than the melting point of most metals. This intense heat causes the filament to incandesce, or glow, producing the bright, warm light we're all familiar with. To prevent this super hot filament from instantly burning out, it's enclosed in a sealed glass bulb. This bulb is either a vacuum or filled with an inert gas, like argon or nitrogen, which stops the filament from reacting with oxygen and rapidly degrading. Now, let's talk about the materials that make up this iconic invention. The star of the show is tungsten. This remarkable metal has the highest melting point of all elements, making it the perfect choice for the filament. To prepare it, raw tungsten is processed and drawn into incredibly thin wires, much finer than a human hair. These delicate wires are then meticulously coiled into a spring-like shape. This coiling isn't just for looks. It compacts the filament, increasing its durability and concentrating the heat to produce a brighter, more efficient glow. The lamp base, which screws into your light socket, is typically made from a conductive and corrosion-resistant metal like aluminum or brass. And of course, there's the glass bulb itself, specially formulated to withstand extreme heat and temperature changes. Finally, we have the internal electrical leads and support posts that hold everything in place and deliver power to the filament. It's a symphony of simple materials working together in a complex and precise way. The first step in creating a light bulb is shaping its most recognizable feature, the glass shell. This process begins with long, hollow glass tubes. These tubes are heated until they become soft and molten. In automated factories, machines then use a technique called blow molding. A puff of compressed air is blown into the molten glass, inflating it like a balloon inside a precisely shaped mold. This allows for the creation of all the familiar bulb shapes we see, from the classic round A-style to elegant candle-shaped bulbs. After it's formed, the glass isn't cooled down quickly. Instead, it goes through a gradual cooling process called annealing. This controlled cooling relieves internal stresses in the glass, making the final bulb much stronger and less likely to crack from the intense heat it will soon endure. Next, we move to the heart of the bulb, the filament assembly. This is a task that requires incredible precision. The tiny, coiled tungsten filament is carefully mounted onto two metal support posts. These posts not only hold the filament securely in the center of the bulb, but also act as part of the electrical circuit. Electrical lead wires are attached to each end of the filament. These wires will eventually extend all the way down to the metal base, creating a complete path for the electric current to flow through. During this stage, quality control is critical. Technicians or automated systems check to ensure the filament is perfectly centered and that the coils are tight and uniform. Any misalignment could cause uneven heating, leading to a shorter lifespan or unstable light output. This delicate structure, known as the mount, is the engine that will power the bulb. With the glass bulb formed and the filament mount assembled, it's time to bring them together in a process called sealing. The filament structure is carefully inserted into the open neck of the glass bulb. The entire assembly is then heated, causing the glass at the neck to soften and fuse around the internal components, creating an airtight seal. This is a crucial step because any leaks would allow oxygen to enter, which would cause the filament to burn out almost instantly. At this stage, a small exhaust tube is left open. This tube is connected to a vacuum pump that sucks all the air out of the bulb. Then, the bulb is filled with a precise mixture of inert gases, like argon and nitrogen. Once filled, the exhaust tube is heated and pinched off, permanently sealing the bulb and its protective atmosphere inside. Now we have a sealed glass bulb with its filament inside, but it's not quite ready to screw into a lamp. It needs its base. The metal base, the part with the threads, is the final major component to be attached. The two lead wires extending from the sealed stem are expertly connected to the base. One wire is typically welded to the threaded metal side, and the other is connected to a small metal contact point at the very bottom, insulated from the threads. A special heat-resistant insulating cement is then applied to the neck of the bulb. The base is fitted over this cement, and the whole thing is cured with heat, creating a strong, permanent bond that holds the base securely in place. This ensures a stable mechanical connection and a safe electrical pathway from the socket to the filament. The final stage in a light bulb's journey is a rigorous series of quality control tests. After assembly, every single bulb is put through its paces. First, they are screwed into a test socket and lit up. Automated optical sensors check for brightness, or lumens, and color temperature to ensure they meet the specified standards. They are also tested for voltage and wattage to make sure they draw the correct amount of power. But the testing doesn't stop there. Random samples are pulled from the production line for more demanding durability tests. These bulbs are subjected to vibrations to test the strength of the filament mounting. Switched on and off thousands of times to simulate real-world use, and left on for extended periods to test their lifespan. Any units that flicker, are too dim, or show any signs of a defect are immediately rejected and removed. Only the bulbs that pass every single test are cleared for the final step. Once a bulb has passed all inspections, it's ready to be packaged and sent out into the world. The finished products are carefully placed into their protective cardboard sleeves or boxes, which not only prevent damage during shipping but also display important information like wattage, brightness, and estimated lifespan. From here, they are boxed up in larger cartons and shipped to warehouses, distribution centers, and finally to the store shelves where you and I can find them. So let's quickly recap. It all starts with drawing tungsten into a fine wire, coiling it, and mounting it on support posts. Meanwhile, glass is blown into shape and annealed for strength. The filament mount is sealed inside the glass bulb. The air is removed, and inert gas is added. The base is cemented on, and the electrical connections are made. Finally, after a battery of tests, the bulb is packaged and shipped. It's truly incredible to think about the journey of this seemingly simple object. From raw materials like sand, metal, and gas to a finished product that lights up our world, the creation of an incandescent bulb is a masterpiece of engineering, chemistry, and precision manufacturing. The next time you flick on a switch and a room is filled with that familiar warm glow, take a moment to appreciate the intricate process and human ingenuity that made it possible. It's a powerful reminder that even the most common, everyday items can have a fascinating and complex story behind them. Thank you so much for joining us on this illuminating journey today. If you found this video interesting, please give it a thumbs up. And don't forget to share it with anyone who's curious about how things are made. For more deep dives into the science and manufacturing behind everyday objects, make sure to subscribe to our channel and hit that notification bell so you never miss an update. See you in the next one.